What is PathDesigner? PathDesigner is a software tool set which creates important efficiencies in the work of the designers of microwave network. These efficiencies are applied in the desktop design process, survey field data collection, regulatory application and report, financial bill of material, and other areas. PathDesigner seamlessly ties to PathLoss 5 and other softwares, taking advantage of each of those software's expert capabilities, particularly PathLoss, while overlaying efficiencies in how they are used. Efficiencies are created by automating manual tasks, that is, as an example, say building layered maps. There's many examples. Providing bulk processing capability. An example is applying new equipment models to many paths, hundreds of paths simultaneously. Linking data sources for all tasks, having a common database so that there's no discrepancies. That applies in engineering, survey, bomb building, and so on. Applying optimization techniques, so selecting the best radios and antennas automatically without having to manually check every case. Automated design is a very powerful feature in PathDesigner, and a good example that we'll see in this slide set is laying out of multi-point networks. PathDesigner enforces a process throughout the life cycle of a project that ensures quality, data integrity, and uniformity, much of which stems from the common database and the common editors. PathDesigner includes specialized features in particular for point-to-multipoint radio networks. The PathDesigner family of desktop tools consists of an engineering platform, a financial platform, and a survey platform, which share data between them through files and have a common database in the background. They also interact with PathLoss reading and writing to the PathLoss files, and also, as I said, to other softwares, such as creating Google Earth files as an example, or ArcMap files. The engineering module ties back to a master database as well, ensuring uniformity of specifications of equipment. PathDesigner's capability include, but are not limited to, importing customer data in many formats, talking to PathLoss in terms of exchanging data between PathLoss 5 link files and GR5 map files. The GR5 map files can also be created from scratch by PathDesigner. PathDesigner also reads and creates equipment files in the format of PathLoss and other formats. PathDesigner creates a multitude of reports and has an intelligent capability to allow you to create your own reports that become templates for future use. PathDesigner creates bill of materials and has a very powerful financial interface. Many map types are created, as I said, the ArcMap, for example, the Google Earth and the PathLoss files are included in that list. There's a very powerful survey and audit tool within PathDesigner, which ties back through the data connections, through the files to PathDesigner engineering. So the data can be exchanged in both directions, and full site audits can be done with this survey tool. There's a regulatory interface in that PathDesigner creates files that are accepted by companies such as ComSearch, and it also reads in the data from the files that come back from these regulatory companies. Most importantly, at the top, there's an automated design capability within PathDesigner to automatically lay out. In this case, I'm showing a multi-point hub and spoke architecture, respecting limitations on megabit site numbers while maximizing the number of connections on each hub. This automated design capability can also include incorporating existing networks and expanding them. As I said, PathDesigner interacts with PathLoss, and I show in this slide the three different views of PathLoss: the link budgets, the profiles, and the mapping. The automation features in PathDesigner There's quite a number of them, and what I'm showing you here is an interface on the left of the PathDesigner editor or process editor to create a multi-point network. And this multi-point network starts only as sites in PathDesigner, um, and it also takes into account all terrain and clutter um, obstructions in the database, or actually in the files that are used within PathLoss, which are in this example are SRTM and the clutter files from the USGS. BTS sites and sectors and azimuths, as well as assignments to the CPEs, are all done automatically, and in this example it was done in less than 5 minutes. There's a point-to-multipoint management capability, so users can edit equipment associated with any particular point-to-multipoint hub and associated CPEs. So in this form, as you can see, there's sector editing at the bottom and equipment editing for CPEs in the center. And there's a lot of automation in terms of how this is done, and it's driven from a master equipment database. PathDesigner, because it ties directly into PathLoss 5, can send map data to PathLoss 5, creating the maps actually, and then within PathLoss 5 heat maps, that is RSL or fade margin kinds of, or even C2I maps, can be created within PathLoss 5. The design process, as I mentioned at the beginning, is enforced by the use of PathDesigner through the use of common data. So this is an example of building a network starting from customer data in the form of a spreadsheet, going through creating all the links and multiple designs, doing capacity analysis, surveying PCNs, and ultimately the bill of material and financial analysis.